All right, let's talk aldehydes and ketones. We're covering both of these at once because they are very, very similar. Okay. So, first up, we have aldehydes, RCOH, versus ketones, RCOR'. Now remember that R is a stand-in, it's a variable, it can be any sort of chain, it could be a halogen, it could even be a hydrogen. Now the point is that we're distinguishing between aldehydes and ketones because aldehydes come at the end of a chain, whereas ketones are in the middle of a chain. Otherwise, you can see they look very, very similar. It is a carbon double bonded to an oxygen. As such, they are somewhat simpler than both amines and alcohols because you can't branch off on the other side of the oxygen. Okay? Oxygens only ever get 2 bonds, so they're both taken up, you're done. You do also have the difference that they are treated differently when they have priority. As a suffix group, your aldehyde makes your main name end in AL, or AL, whereas your ketone makes them end in ONE, for OWN. So this here would be butanal, and this would be butanone. Okay? So you can see that it's still very similar to the organic chemistry we've dealt with so far. 4 carbons, no double bonds, AL. 4 carbons, no double bonds, ONE. When they don't have priority, they are treated the same in that they are oxo. Okay? Make sure you go ahead and distinguish these from the ethers. Okay? Those were something oxy. This is just oxo, okay, by itself. So all it's referring to is, the fact that there is that oxygen double bonded to a carbon somewhere on the chain, in any event, in any case. Now, as for priority, aldehydes take priority over ketones. So we have aldehyde, ketone, alcohol, and then amine. And that's the list of priority as we have it so far. Now, something that can get confusing, as we move forward, we'll see that there are other functional groups that have a carbon double bonded to an oxygen in them, as part of them. Okay, and you're going to have to make it a point to distinguish those from the aldehydes and the ketones. So, for example, RCOOH, that's a carboxylic acid. RCONH2, that's an amide. Okay? RCOOR' is an ester. Okay? So there are those three. Those are the 3 ones we will be covering, and you'll see that each one has that carbon double bonded to an oxygen right there in the middle of it. And you're just going to have to make it a point to remember and recognize those when we come to them. But we're not going to be covering those this week. Okay, that'll be next week is when we start covering those. But for now, you see the carbon double bonded to oxygen, it's an aldehyde or a ketone. Just be aware that it's not always going to be the case. So let's look at naming some of these, yeah? Okay, we've already covered 2, butanal, butanone. Now, the aldehydes give us, one simplifying grace. They always come at the end of a chain. So you don't necessarily have to number them. Okay? If they have priority, they always get priority in numbering, right? The other advantage is that the most you can have on any chain is 2 ends. Therefore, the most you can get is 2 aldehydes on a single chain, dial. If it's not part of the main chain, it's no longer, a suffix group, and therefore it's just going to be an oxo somewhere in the prefixes, right? So this here, we have 1, 2, 3, 4 carbons. And you see we have two aldehydes, one at either end, so it's butane di-al. Okay, it's a dialdehyde, one at either end of the chain. We don't need to number it, just like we didn't need to number for the butanal. Okay, the aldehyde can only come at the end of the chain. It has priority, so it's number 1 on that chain, and therefore you don't need to number it, butanal. Unfortunately, the same is not true of the ketones. Okay, the ketones, they can show up anywhere on the chain so long as, they're not number 1 on the chain. So 1, 2, 3, 4, 5, 6, 7. So this is heptan 2, 3, 6 trione. Okay. So you're usually going to have to number your ketones, just because they have a lot more flexibility in terms of where they can show up. There's one definite exception that I can think of off the top of my head, and that's this guy. Okay, you have 1, 2, 3 carbons. The only way it can be a ketone is if it's on the second carbon. So that would be propanone. Okay, because there's only the one place the ketone can go. That's the only place it can be. You don't need to number it, propanone. Except for the fact that, unfortunately, this guy has a common name. So we might as well go ahead and take a look at that real quick. Technically, it's known as acetone. I usually dislike common names because they're not altogether systematic. This one is worse than normal, because normally this acet prefix means, you have 2 carbons. So acetic acid looks like this. 1 carbon, well, technically that's the second carbon, then the first carbon. Then you have the double bonded oxygen, you have the OH, 2 carbons, right? Acetic acid. Okay. Similarly, you have acetaldehyde, looks like that. Again, just 2 carbons, and then the aldehyde on one of them. Okay. So, you can sort of see where they're coming at with the acetone, okay, because, it's sort of like you have the acet, and then you have a CH3 group coming off of it, but I like it even less than that. The reason I'm showing it to you is not only is it a common name that you're likely to run into because of old people, it's one that I don't think will ever go away, because acetone is an incredibly, incredibly common organic solvent. You will find it in every chemistry lab ever. Well, not the theoretical labs, all they have is computers, but the ones where they do actual work, because it's so useful for cleaning glassware and so on. You just always run into acetone all over the place. You've probably encountered acetone in your own homes. It's fingernail polish remover. Like I said, it's just an incredibly common, very useful organic solvent. That name's not going anywhere. But we can continue with the common names, because we also have, well, I've already shown you this one. This one is acetaldehyde. Okay, it's an aldehyde on an acet group, right? Acetaldehyde. Technically, it should be ethanal, but most people would probably call it acetaldehyde. This one here, the ultimate aldehyde, it doesn't even have a chain on the other end, it's just the 2 hydrogens. This one technically should be methanal, but it's got another common name that I think you will always run into, and you've almost certainly heard of this guy. It is formaldehyde. Yep, the stuff they use to preserve things. Okay. So, I mean, you wouldn't get in trouble for using either of these, like on a test or on a homework or something. And most people, I think, would understand what you meant after a second or two to work it out for methanol and ethanol. But definitely they would be more familiar with formaldehyde. And I feel pretty certain they would be more familiar with acetaldehyde, even though those aren't as good. They're technically wrong. And finally, the one you had to know was coming, benzene. You cannot get a ketone on a benzene ring just because the carbons don't have bonds free to do that. You also can't get an aldehyde on any ring because an aldehyde only shows up on the end of a chain. Rings don't have ends. Okay, but if you have an aldehyde sticking off of a benzene ring like this, then what that means is that you have benzaldehyde. Okay, shows up quite a lot actually. It's well, actually, I shouldn't say that. I don't know how often it shows up, but it's one of the common names dedicated to benzene. So benzaldehyde. So let's do some more naming practice real quick. Here we have a ring. Now those guys can't be aldehydes, like I just said. So those are ketones. And we have 1, 2, 3, 4, 5, 6 carbons on there, so it's cyclohexane 1,4-dione. I don't feel like looking it up, but I'm fairly certain that this also has a common name. So you probably won't ever run into cyclohexane dione out there in the world. But I can't remember what the common name is at the moment. So I'm not going to try and make you suffer with it. Now let's see if I can't throw something more complicated at you, something that has some oxos on it. Okay, so O. Okay, so we definitely can't get all of those on the main chain. Now, as for what the main chain is going to be, well, remember, we have 1, 2 ketones and 1, 2 aldehydes. So, aldehydes have priority over ketones, so our main chain is going to have to include both of the aldehydes. And in this case, it's not going to include either of the ketones. Okay, the ketones are not going to show up on the main chain, because the main chain is going to go from one aldehyde to the other. As for numbering, well, that will have to wait until after we've named the side chains. So we have one side chain here, one side chain here, and one side chain there. Okay, so this here is a methyl group. Here we have 1, 2 carbons, so that is a 1, oops. That is a 1-oxo-ethyl group. Here we have 1, 2, 3, 4, 5. So that is going to be a 3-oxo-pent-2-il. So in alphabetical order, LMNO. So that means that this guy is going to come first, the methyl group. So we number from this end. I'll choose a different color for that. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now that means that this bad boy is going to be 3-methyl for 1-oxoethyl, 7 3-oxo-pent-2-il, octane dial. So, yeah, that's a pretty very long name, but that's the sort of thing that happens when you try to include suffix groups as prefix groups without putting anything higher priority on. So let's look at something a little simpler that includes both an oxo and a keto, an aldehyde and a ketone on a single chain. Okay, this is a much simpler chain. Remember, the aldehydes get priority, so 1, 2, 3, 4, 5, 6. Okay, making this a 5-oxo-hexane al. And that's all you have to do. Okay. For those of you who have been wondering, these double bonds, no easy. Okay, that only works when the double bond is between carbons. Okay, so you're not having to worry about easy for double bonds between the carbon-oxygen double bond. Now, just to throw a bit more nomenclature at you. Okay, C double bonded to O, R, R prime. Okay. This is known as a carbonyl. Okay, so we call this the carbonyl carbon, and this is the carbonyl oxygen. That's something that shows up a heck of a lot in organic chemistry. It might show up some in biochem. I don't know about that, but I know it definitely shows up in organic chemistry because this is a delta plus, this is delta minus, because it's a really electronegative bond. It's got a lot of electrons in the double bond. Then you got these right here, the non-bonding electrons. So there's a lot of different kinds of reactivity going on in that one location. So different organic chemistry reactions will focus on the carbon or the oxygen, and they'll ignore other parts of the molecule in favor of attacking one or the other of those, is often what happens. You also definitely see aldehydes and ketones showing up a lot in biochem and in organic chemistry. So, for example, okay, what I'm sketching out here is basically just COH and then H. What I'm sketching out here is, unless I've completely screwed up, which is entirely possible. Actually, this might just be CH3. Yeah, I'm pretty sure that's what that is. A sugar. 5 membered sugars and 6-membered sugars usually have just alcohols all over the place and either a ketone or an aldehyde. Depends on the sugar. So they show up all the time. You'll also find what are known as ketone bodies showing up a lot. Well, not necessarily a lot. Ketone bodies are of significance because when your body is having difficulty metabolizing sugars, it will start to break down other things. And you'll get what's known as a buildup of what are known as ketone bodies in the blood, as metabolite byproducts are sent to the liver to be broken down and dealt with there. These cause a distinctive odor. It smells kind of like paint thinner. You'll notice that scent, the scent of ketone bodies, you'll find it on the breath and in the sweat of alcoholics and diabetics. For various reasons, they both tend to have a lot of ketone bodies in their blood. Also, people who are starving to death. That's a little bit less common these days, in the U.S. at least. But they also end up with the ketone bodies in their blood. So there's a distinctive odor there that you may have noticed in strangers, on the street, or in people you love, or what have you. But that's one of those things that can serve as a warning sign for health problems, because you don't want those high levels of ketone bodies in the blood. For diabetics, for example, I know it can lead to ketoacidosis. I think that's what it's called. I probably shouldn't go into too much detail there because I'm not on firm ground here. But it's basically it can lead to death. So, all right. Ketones, aldehydes, common names. I think that covers everything. See you around.